Evaluating trigonometric functions. All right, so here's the thing. Most scientific calculators will only have buttons for sine, cosine, and tangent, where you can plug in any angle in degrees or in radians, and you can get an answer out of it. Some calculators are nice and they'll give you nicer answers, like with radicals in them, and other calculators aren't as nice. But regardless, most scientific calculators, I'd go as far as to say all scientific calculators have a sine, cosine, and tangent button. Now, here's the other thing. They don't have buttons for secant, cosecant, or cotangent. And they don't have buttons for them because we can rewrite each of them using their soulmate. So secant is 1 over its soulmate cosine. Cosecant is 1 over its soulmate sine. Here, let's just like write out them again. You can't ever write the soulmates enough times, truly. You can't do it enough. Cosine of theta, soulmate is secant. There's 2 with C's and, well, there's secant and cosecant, and there's sine and cosine. So there's 2 C's and 2 S's there. And then obviously there's another C, but cotangent and tangent are obvious that they're together. So cosine and secant, those are soulmates. Yes, this is important. Yes, you have to write the hearts. You won't be able to learn the math unless you do the fun things. All right, sine of theta. Soulmate is cosecant theta. And then tangent of theta, soulmate with cotangent of theta. All right. What that means is that their function, whatever they spit out, their soulmate is the reciprocal of that. All right. And reciprocal, by the way, it's the same thing as just flipping the fraction. All right. Use the reciprocal identities and a calculator to find the following values of trig functions at the indicated angle. Give your answer as an exact value. All right. It says to use a calculator, mostly because I want to show you how you would do this if you were using a calculator. I'm going to set it up and tell you where you can push enter, but I'm going to then do the rest of the work by hand. So let's do this. Cosecant of theta, who's their soulmate? Oh, it's sine. So cosecant of 17 pi over 3 is the same thing as 1 over sine of 17 pi over 3. So you might be like, right, but then what is 17 pi over 3? So you could push enter on a calculator right now. This you could enter into a calculator. Make sure your calculator is in radian mode. There's 2 modes on your calculator. It's either going to be rad for radian or deg for degree. Sometimes it's just an R or just a D. You could look in your calculator's manual. You could ask ChatGPT how to turn it into radians on your calculator model. It would figure it out for you. Anyway, you could push enter here. However, we're going to do this manually. So I want to come over, let's take a new page here. Oh, no, it didn't paste the thing I wanted it to. Oh, yes, it did. I just pasted it here. All right. Well, hold on. All right. So let's just focus in on sine of 17 pi over 3. So sine of 17 pi over 3, we can find a coterminal angle for 17 pi over 3 that's between 0 and 2 pi. 2 pi. Oop, I'm not used to having, I changed the mode. Okay, hold on. Hold on. All right, there we go. Coterminal angle for 17 pi over 3, that's between 0 and 3 pi. Not 3 pi. My goodness. 2 pi. Just making sure you're on your toes. Hope you didn't pause the video immediately after I said that and get angry. All right. This would be the same thing as 0 pi over 3. You might ask me why I'm choosing 3, and it's because that's the denominator, using that same denominator. And then 2 pi, with regard to pi's over 3, are 6 pi over 3. So we're looking for the numerator to be between 0 and 6 pi. So I'm just going to keep on subtracting 2 pi's. And when I subtract 2 pi, it's going to look like this. So 17, oops, nope, there. 17 pi over 3 minus, let's do it red, minus 6 pi over 3. The math you're doing here is truly 17 minus 6. It really is. Just show you down here how that math could work without me writing a single fraction down. 17 minus 6, that's 11, or no, yeah, it's 11. That's not small enough. It has to be between 0 and 6. So 11 minus 6 is equal to 5. The answer is going to be that it's coterminal with 5 pi over 3. And so I could do this without writing any fraction math down, but I want to write it down the first time just so that it makes sense. All right, this is equal to 11 pi over 3. That's not small enough. It has to be between, the numerator has to be between 0 and 6. So 11 is too big. So 11 pi over 3. And we subtract another 6 pi over 3. So 11 minus 6, that's 5. So you can see where that math was coming from. 5 pi over 3, and that is between 0 and 6. So that is coterminal. So 17 pi over 3 is coterminal with 5 pi over 3. 5 pi over 3, that's right here. Maybe I should make that a different color. Orange. That's right here. We were looking for sine of 17 pi over 3. So sine of 17 pi over 3 is the same as sine of 5 pi over 3. So because these are coterminal, sine of 5 pi over 3, that's the y value at that point, which is negative root 3 over 2. All right. So what I can say now is that sine of 17 pi over 3 is negative root 3 over 2. I'm going to take it, boom, paste it, right? Just replacing the 17 pi over 3, sine of 17 pi over 3 right here. I'm going to simplify this fraction. I'm going to multiply the numerator and the denominator of the big fraction by 2. So I end up with 2 over, and I'll just move the negative sign up here because I can do that. Boop, boop. I'm going to get rid of those. Negative 2 over, not negative root 3. Already moved to the negative. Negative 2 over root 3. So final answer, cosecant of 17 pi over 3 is negative 2 over root 3. You do not need to rationalize it. If you did rationalize it, it's totally fine. It's the right answer still. They're both right answers. But it would be -2 root 3 over 3 if you rationalized it. This guy here. All right. Secant of -3 pi over 2. So again, we're looking for a coterminal angle. I'm going to do the math. So we're looking for an angle between 0 and 0 pi over 2 and 4 pi over 2. So we want the numerator to be between 0 and 4. I'm going to do the math real quick on here so that I'm not writing out every step, but maybe you can kind of follow along with the logic there. So the numerator starts out as -3. We can see it right here. Starts off as -3. Maybe I'll make that. There we go. I need it to be bigger, so I'm going to add 4. That's the same thing as 4 pi over 2. And that gives me 1. 1 is between 0 and 4. And that means that -3 pi over 2 is coterminal with, okay, and on a 1 pi, so just pi, over the denominator was 2. -3 pi over 2 is coterminal with pi over 2. So secant of -3 pi over 2 is equal to 1 over cosine of -3 pi over 2. But cosine of -3 pi over 2 is the same as cosine of pi over 2. So it's 1 over cosine of pi over 2. So that's the x value at pi over 2. That's what cosine of pi over 2 is. All right, so let's go. Where did that one go? Here it is. Of pi over 2. We wanted the x value, so 0. This is 1 over 0. Oh, we can't divide by 0. That happens. So in this case, secant of -3 pi over 2 is undefined. And by the way, when you go to plug it in, you could just plug in this without converting the coterminal angle. You don't need to, you could just 1 over whatever the soulmate is, plug it into a calculator to give an answer. All right, cotangent of -140 degrees, so much easier to deal with degrees, right? And I guess you can always change. It's a tangent here, but hey, you're in it for the whole video at this point. Might as well stick around, right? It's worth it for some students to change from radians into degrees because the math isn't that bad. So we multiply by 180 over pi. And then you have, let's see, 36 plus 18, 36 plus, let me not make bad math on this video. 3 times 180, 540. So -540 over 2, and the pi's cancel. Right. 270, -270 degrees. So you could have changed this into degrees to begin with, and then you don't have to deal with any of the pi math there. And that does work because you would just add 360 degrees and you'd get 90 degrees. And 90 degrees is the same thing as pi over 2. 90 degrees is pi over 2. Anyway, that was a where where is it? That was a tangent, my friends. That was a tangent. Okay. So yeah. Cotangent of negative 140 degrees. That is the same thing as, let's do the math up here, negative 140 plus 360 is 220. And that is between 0 and 360. So it's the same thing as cotangent of 220 degrees, which is 1 over tangent of 220 degrees. Go to our unit circle for 220 degrees. Ooh. Oh man, I'm certain that I meant for that to be a different number. Hold this recording. All right, so here's the thing. I mean, I definitely meant for this number to come out differently when I made this worksheet. But however, let's just treat this as a learning opportunity. We're probably not going to get an exact answer. We're probably going to get a decimal here. But here's what you have to do. If this isn't on your unit circle. 220 is not on your unit circle. You just need to plug this into your calculator. So that's what I'm going to do. I'm going to look at my calculator. My calculator is in degree mode as I have a D on it. On the top of my screen, I'm using a Casio calculator. I think they're the superior scientific calculator on the market today. They don't pay me, but they should. All right. I'm getting, let's round to the nearest 100. I'm getting 1.19. 1.19. All right. Secant of 930 degrees. So we're going to play the same game. 930 degrees minus 360 is 570. Oop. 570 minus 360 is 210 degrees. This one we can work with. So secant of 930 degrees is the same thing as secant of 210 degrees. Secant soulmate is cosine. So this is 1 over cosine of 210 degrees. That's going to be the x value at 210 degrees. Negative root 3 over 2. So negative, this is 210. X value, negative root 3 over 2. Oops, but not like that. 1 over negative root 3 over 2. I would clean up the answer a little bit, multiply by 2 on the bottom and top, and then you would get negative 2, negative 2 over root 3. And I wouldn't bother rationalizing. Also, this one right here, ooh, secant of 930 is equal to that. Cotangent of negative 140 is equal to 1.9. Okay, cool. Last bit. So here's some notation right here that you're going to need to know. This notation right here, sine squared theta. When you see that, when you see sine squared theta or cosine or tangent, doesn't matter, any of them, this means you take whatever you have of sine of whatever the angle is, and then you square it. It does not mean, is not the same thing as sine of theta squared. All right, sine of theta squared would be different. Sine of theta squared would be squaring theta, not the entire thing. So we want to square the entire thing. That's why the square is here and not over here. All right. So we're just plugging in 225. So we have sine squared of 225 degrees. And that's the same thing as sine of 225 degrees. Let's do it. 225 degrees, all squared. That's going to be the y value at 225 degrees on the unit circle. The y value at that spot, 225 degrees, the y value is negative root 2 over 2. The whole thing is squared. If you square negative root 2, you're going to get positive 2. If you square the denominator, which is 2, you get 4. And that simplifies to 1/2. All right. Plugging in 225 again. So we have sine of negative 225 degrees. I'm going to find a coterminal angle. So I'm going to do negative 225 plus 360. And I get 135. And I'll make that a little smaller. So this is the same thing as sine of 135 degrees, because negative 225 is coterminal with 135. This is going to be the y value at 135 degrees. 135 degrees, the y value is root 2 over 2. And that's it. We're done. And then sine of 2 theta, instead of theta, we have 225. This is sine of 450. We need a coterminal angle. So we'll do 450 minus 360 degrees. That's 90 degrees. So this is equal to sine of 90 degrees. That's going to be the y value at 90 degrees. Looking at the unit circle, the y value at 90 degrees is 1. 9 degrees, 1. Woo! All right. All right, that is the end of this worksheet. Hooray. All right, so that's that for this section. This is a wild section. It's a really, really important section. If I could make you redo sections later in the semester, I would want to redo this one because there's nothing more important than it. So please take the homework seriously. Take the time to learn the material. It'll benefit you later on. And I'll see you in another video. Bye.